Welcome to Mastering Solutions. In this coordinate systems and vector components problem, they give us three vectors, d, v, and a, and they ask us to both draw them and then find the x and the y components. So first, let's just go quickly through and draw these. So for a, or vector d, they tell us that the magnitude is 100 meters and it's 45 degrees below the positive x-axis. So this is the x and this is the y. It's below the positive x. And it's 45 degrees, so it's down like this. We'll say this is 100 meters, and that is 45 degrees. And so for B, or vector V, we have 300 meters per second is the magnitude, 20 degrees above the positive x-axis. So here we have 300 meters per second, and that is 20 degrees above the positive x-axis. Lastly, for vector A, we have 5 meters per second squared in the negative y direction. So in the negative y direction, they're telling us that it's going straight down. So we have it like this, and that is 5 meters per second squared. This one we said was 300 meters per second. Okay, so now we've drawn all three of our vectors. So let's go through them one by one and figure out the x and the y components. For A, so for vector D, let's write it like this. We'll have d sub x for the x component and then d sub y for the y component. So for the x component for this one, we need the positive x value right here, which is adjacent to the angle. So adjacent in this case, we'll be using cosine because we have the angle and hypotenuse and we need the angle. So cosine is equal to adjacent over hypotenuse. We want to isolate a, so we'll multiply both sides by h. We have h. So h in this case is 100. So for the x component, it's a positive 100 times the cosine of the angle 45 will give us the x component. I'm going to wait and I'll plug the values in for x and y together just to save a little bit of time. So now for the y component, we need this value right here, and it's in the negative y direction. So we need opposite of the angle, and we have the hypotenuse, so we'll be using sine. And sine of the angle is equal to opposite over hypotenuse. We'll do the same thing to find the opposite. So we have h, in this case again, is 100 meters per second times the sine of 45 degrees will give us the y component. So 100 times the cosine of 45 will give us the x component, or 70.7, or we can round that to 71. And then for the y component, we have 100, and the y component is negative, so it needs to be negative 100 times the sine of the angle 45. So that gives us negative 50 root 2. So we have negative 71. So we have positive 71 meters for the x component, and the y component, because we're going in the negative y direction as we talked about, is negative 71 meters. For B, we'll do the exact same process. The x component is adjacent to the angle, and we have the hypotenuse, so we'll be using this. So for vector v sub x and vector v sub y, the x component, as we said, is the cosine, so we have the hypotenuse is 300 meters per second times the cosine of the angle, which is 20. And then for this one, it's the exact same. For the y component, it's the opposite of the angle. So we have the hypotenuse, so we'll be using sine. So we have 300 times the sine of the angle 20. So 300 times cosine of 20, and the x component in this case is in the positive x direction, so that's correct. The y component is also positive, so that will also be positive. And so we have 282. We'll round that to two significant figures. So we'll have 280 and 100. So 280 meters per second and 100 meters per second. So there's the x and the y components for vector v. Lastly, for C, we only have a y direction. So this one's pretty easy for vector A. A sub x there is no x component to it. So it's 0 meters per second squared. So the a vector in the y direction is only y, and it's in the negative y, so it's a negative 5 meters per second squared. So here are all your answers for vectors a, v, and d for the x and the y components.